Okay, so thanks for joining, guys. I don't know where the others are, but this will hopefully provide.
Sorry, it was like I think last only minute in the day where there were 6 people asking for coffee.
Yeah.
Usually
Great.
nobody
It
does.
was PMP.
Yeah, the entire PMP team.
Yeah.
And now
Always
everyone listening to this recording will know that you were waiting for coffee. I literally just started recording the presentation, so that's okay.
Name and shame.
Yeah. Yeah. So everyone will know you were late. What I was explaining to these guys is that I don't know your background. Some of you may be experts on test-driven development. The point of this is to get everybody on the same page. And then once we start doing development again, then we can decide, if anything needs to change or, what we like, what we don't like, and so on. So, like I said, the goal is just to get on the same page. And I kind of wanted to start with an interesting analogy from Kent Beck. So, from this book here, he talks about test-driven development being like pulling a bucket up a well. And if you think about it, if the bucket is light, it's empty, you can just use a wheel and crank the bucket up the well, right? But as the bucket becomes heavy, you need some sort of a ratchet mechanism to help you get the bucket up the well, because you'll get tired, right? You want to have a ratchet, and then you can rest, and then start to crank some more, right? The tests that you write in test-driven development are like the ratchets. And so as the bucket gets heavier, the teeth need to be closer together. And as the programming problem becomes more difficult, the tests will do less and less. They will slowly get you closer and closer to the final solution. Once you write a passing test, it's passing forever until the end of time, right? And you're that much closer to the final solution of whatever it is that you're trying to develop. So I thought it was an interesting analogy I wanted to share. Thought it would be a good introduction point. What the hell do I know? In other words, who am I to be presenting to you guys, right? I'm still new here.
You own the book, so I feel defeated already.
Right. Well, thank you. Appreciate that. But like Max has been here a while. Sridar's been here a while. I've only been here a few months. I just wanted to say, this is not the first time I've given this talk on test-driven development, so I've had a chance to kind of get familiar with kind of questions that people might ask. But I've done the obvious things like reading online articles from Martin Fowler and Mike Kahn on the issue. I've read, watched some interesting blogs on YouTube. There's a lot of interesting content out there just to draw in information from different sources. Also, as I've already mentioned, read this book by Kent Beck. Kent Beck is perhaps inaccurately given credit for inventing or creating test-driven development. He sort of is the one that made it the way it is as we know it today. But it's existed for much longer. It's just he's kind of popularized it and formally defined it and made it the way that it is now. So he's an excellent source of information on the subject. And also at my previous job, we were doing test-driven development, so I have some experience.
Like you?
No, we were actually developing. Okay, so but the first thing that, before we really kind of get started talking about some of the test-driven development stuff, I wanted to talk about the importance of unit tests. Mike Kahn and Martin Fowler both talk about the test triangle or test pyramid. Sorry. So what you see here is your foundation of tests should be this wide base of unit tests. And then as you go up the pyramid, you have a smaller set of service or integration tests, and then at the top you have your UI tests and then even manual tests, right? And you can see from the left that on the bottom these should be very fast. At the top these are going to be slower. And the cost on the right is much lower at the bottom, and then much higher cost at the top to run these tests. An anti-pattern of this is the ice cream cone, which maybe some of you guys know. This is where you invert the pyramid, right? So you've got your unit tests at the bottom, a teeny little portion of your tests, and then your integration tests in the middle, which is like your service layer sometimes, and then the wider set at the top. And this is called the ice cream cone.
Well, here as well.
So, yes.
I seem to be striving for the fattest integration layer possible, to be honest.
Yeah, and I was that's what it was that I wanted to say.
I wasn't
So,
serious up there, but we kind of
Right, so, and this even was happening at my previous company as well, where we had more of like an inverted hourglass, where you're narrow at the top and narrow at the bottom, but then you've got a real fat middle, right?
So the reason I'm pointing at that is that we worked on a program database, and despite this being well broadcast wisdom, there was a hell bent on doing this kind of inverse pyramid with really expensive end-to-end tests, which kind of had to have every case covered. There's a whole team of people doing this, absolutely miserable. It took forever to get anything done, and yet there was no drive to go towards that.
Yeah.
But yeah,
are you saying that is a good pattern or?
It's an anti-pattern, so it's not a good pattern.
So our current code also seems to be the same, right?
there are.
Yeah, but what we're
there's
saying
definitely
is is this like at the end we have QA session or?
No, of course not.
So it depends what you find about integration. So I agree with you that we are. It's a bit unfortunate we don't have a idealistic pyramid, but integration can mean even higher level, right?
Yeah. So other thing
That's
which
true.
I want to say is like in my previous projects where we have written unit tests as well integration set. So the point is it's a repetitive. We repeat the same test again and again. So it's not like like a pyramid, it will be like a square. So we don't know, we cannot differentiate what test to write it at each level and what
We
test to
definitely have a bit of a square going because we have a square going on with Italy at the moment, right? People in Italy are doing the same things that Rune and Luther are doing, and they're also sort of a slight subset of what we're doing. So there's a pretty.
So
It's a bit
suppose
scary.
if you are writing exposing a REST API where you are having CRUD operations, you write in the DAO layer the same test, service layer again same test, and integration same test. The cucumbers are same test basically.
This is a very good point because this is why I don't like at all our testing system, because I truly believe that you should never think if adding a unit test you can add as many as well because they are so cheap to add,
Yeah.
that you should do like even if you think it's done, just do it. But we have like too many what is comparable to UI
So
tests.
I'm going to continue. One thing I forgot to mention was that for this talk, I kind of wanted to take myself out of the context of Gonzalez and just present the material really. So if you find yourself kind of trying to apply some of the things that I might say to what we're currently working on, and it doesn't sound like maybe it sounds like it conflicts. The reason for that is because I'm just pulling myself out of the context of our current project and just presenting the material. So yeah. Anyways, so that's all. I just wanted to show those somewhat briefly. Okay. Now let's actually get into some of the test-driven development stuff. Okay, so let's talk about the goals, right? Because when you think about test-driven development, or at least what I thought of with regards to test-driven development when I was first, getting into this was like, everything is tested, right? That's the goal. That's what I thought at the time. And I think that's a common perception for a lot of people. But actually, what the I would say primary goal of test-driven development is to improve your design and have clean code that works, right? And so I really love, or I wanted to share this quote from Martin Fowler where he says, TD's origins were desired to get strong automatic regression testing that supported evolutionary design. Along the way, its practitioners discovered that writing tests first made a significant improvement to the design process. And that's also why it's called test-driven development. You drive everything that you're developing using these tests. And so, I don't know, make sure that we should all have the common understanding that that is one of the primary goals of test-driven development. Yeah, and then we can now talk about some of the different styles, variations of test-driven development that there are. There are two styles of test-driven development, and really these come down to two styles of the way that you interact with your dependencies. So the first style is the London style, and this is the Mockist style.
Interesting.
Yeah, and the reason it's called the London style is because this is where this originated. You also have the Detroit style. This is the classic style of. Yeah, perhaps. I think you're probably right, actually. But so with Mockist, you have mocks, right? Maybe you're roughly familiar with what mocks are. We'll talk about it more in another slide. But with Detroit style, you're using stubs versus mocks. So we'll talk about the difference between those things, and probably had to answer a question for your interview for that. So, anyways, we won't. I don't know. Maybe we won't spend too much time on it, but we'll go over that here just to, I don't know, get on the same page, right? So, what is the difference between mocks and stubs? And I don't know if now is a good time to say it, but what I found from my experience is that you weren't always just one or the other. Sometimes you may always prefer to be this London style, right, using mocks everywhere. But then you may find yourself in a situation as you're writing a test that it may be more convenient to use a stub to, okay, I don't want to mock this thing because I'd have to verify all these different calls on all these different methods. And rather than doing all that, I just want to get the results from the stub, verify that the results are what I want, and be done with it. There's no impact on how fast the test runs, whatever. So anyways, you're not always necessarily just one or the other. Okay, so the difference is essentially this: behavior versus state verification. So with mocks, you're doing behavior verification. You're verifying the way that your class under test interacts with the objects that you've mocked. You're verifying that the get movie key or get movie title method has been called 3 times after you call your class under tests search method, for example. So that would be an example of behavior verification. With mock, yes, so you're verifying the interaction of the objects. Then with stubbing, you're looking at the results. So I don't know, say you're unit testing some mail service, and if you have a server stub, you might just get all of the emails that are on the current server stub rather than verifying that send email has been called on the server 20 times. I don't know. Maybe that's not a great example, but the idea is with stubbing, you just care about the results. You don't necessarily care how you get there. It's almost like, you can almost think of it like you're treating the dependency as a black box. I think that's a good way to explain it. Is that somewhat clear? I mean, okay, maybe you guys already know these things, but
It's a good way.
okay, great. So let's move on. I don't want to spend too much time on this stuff, but yeah, it is important to kind of make sure that we all are on the same page. So when do we use test TDs, test-driven development? So this was a question that I had when I first got started. I didn't know, like, okay, I mean, am I just always doing test-driven development? Like, what do I write a test for? When do I write a test? When do I not write a test? You know, like, if I'm developing a new class, how do I know? When do I do test-driven development? You know, Ken Beck has an amazing quote on this that gives you a good rule, which I'll share with you. It's write new code only if an automated test has failed.
But hold on, this is something, sorry, I didn't get the question. Are you saying that when to use TDD or when to write a test? Because TDD means like writing the test before, right? And writing a test, I think you should always write tests.
Yeah, I mean, I think that when we say TDD, we're talking about writing a test. I mean,
Beforehand, right? Because TDD is the exercise of writing a test before writing the code.
right. So that's why he's saying it's weird. When I first read this, it was like strange to me. I was like, how
You
is
have to
that
think about it,
possible?
don't you?
Yeah, I was like, what is that? I don't get it. Like, how's that possible? How would you have a? Because in my mind, you know, at the time, it was like, okay, our automated tests are checked in and running nightly, and like, I don't get it. But it's write new code only if you have an automated test which is failing. So in other words, you write the test first, it's failing, then once you have the failing automated test, you go and write the code to make it pass. And that's the only time that you write new code. New code is once you have that failing automated test. So in other words, it's always for everything. Yeah, and even your test doesn't even have to compile initially. So you know, what I would do is, and I don't know what you guys have done, but what I would do is I would just type the test exactly how I wanted things to be named. If it was an interface that I needed to create, I would just write the name of the interface and the method exactly how I wanted it, whatever made sense in the context of the test that I was writing. And then once I kind of had the structure of the little tiny test that I was writing the way that I wanted it, I would go create the interface, create, you know, whatever else it is that I needed to create to make the thing compile, and then run the test, and then it would fail, and then go and implement the method I needed to implement. So all as far as what to test, all public methods of the class under test. So in other words, you would write a test for each of the public methods, and you would have one test class. Typically, you would have one test class per class that you're testing. But Kent Beck talks about having multiple test classes for a single class under test. And the reason for that would be, and I did run into this a few times, the reason for that would be if you're creating what he describes as a fixture. A fixture is like a complex configuration of a mock or a stub maybe that has to behave a certain way. Like say you have some, I don't know, search mock that has to behave a very specific way for a set of tests. And then for another set of tests, it doesn't really make sense to behave that way. Rather than confusing your one test class with the two different configurations of the mock, the fixture, you would put them in separate classes, separate test classes, but they would both be testing the same class under test. That was less common, so you can maybe initially think of it as just a one-to-one kind of thing, but yeah, it is possible to have more than one test class per class under test. Yeah, and that was my point here with the ratio. Okay, so let's just quickly look at an example of a unit test. I'm not sure what I really want us all to get out of this, other than to point out that this is the London style. So we have some mocks here. we okay, there's a few things I want to point out here. So in the unit test, I have broken into 3 different parts. So what's very important with your tests is that they're readable. Readable for you at that given time, but also readable for anybody that may come across this in a year and need to fix a failing regression test, a failing unit test. So they have to be able to come here and look at this unit test and know exactly not only what this test is doing, but also what it is that you're trying to test. So what I've done is I've just separated the definition of the behavior of the mock from the actual method that we're invoking, and then I always put the, I have my assertion here, and then I verify that behavior on my mock here. One thing that I did, which is not how, okay, I said I wasn't going to talk about this in the context of Gonzalez, but I had a discussion here on this, so I'll just quickly mention it. What I did is I named this method, the name of the test method, according to the name of the method that I'm calling on the class under test. Followed by the input to that method. And then the last thing is the expected result, the expected output, or if it's like, expecting to throw an exception, then I would put that here, and so on. I know that we haven't been doing that here, and that's fine. It's not a hard rule. This was actually something that I had learned from some video blogs. This isn't anything that Kent Beck or any recognizable names had talked about. It was just something I saw on a video blog that I liked, and because I do know the importance of communication and readability on all these unit tests, I felt it was a good pattern to follow. So anyways, I'll move on. How to TDD, red, green, refactor, repeat. Probably know this pattern, probably familiar with it. Think of it like a finite state machine. There's a few critical components to this that I do want to highlight, which is you move through this cycle of red, green, refactor very quickly. So it's not like, you go through this cycle twice a day, and that's it. You would spend maybe 15 minutes on one full cycle, 30 minutes maybe. If you start to get to a point where it's taking longer, then what Ken Beck suggests doing is scrap the whole thing, and try to limit the scope of your test even more. Break it down to an even smaller ratchet size, and move through the cycle much faster.
Again, claiming not to talk about Gonzalez. This is where the 20-line Cucumber tests make this really, really painful. You want to test one thing, and it's an incomprehensible test that is likely to fail. This is impossible in that way, right?
Right. So that was one thing that I wanted to highlight is, you move through these steps very quickly. Kent Beck talks about being addicted to the green, so he won't even go to the bathroom if he's in red. He forces himself to get to green first. That's a little bit silly, but anyways, Kent Beck's kind of a silly guy. That's why it actually makes reading the book quite enjoyable, because he's got a great sense of humor.
Say that he's on the same place.
Yeah.
Oh,
He's on
yeah.
the same place.
But that's the one that we created the money service, the example. The one is the TDD by example. That book, the one with the money, with the currency.
Yes.
Right?
Yes.
Because I only read it, like download it.
The other thing that I want to the other thing that I want to highlight here is this write minimal code on the making the test pass state. So when you're in red and you're trying to get to green, you write the absolute minimal amount of code necessary to get back to green. Then, you, as Kent Beck describes, you commit whatever sins necessary to get to green. Then, once you're there, you move to the next step, which is refactoring, and that's where you remove any duplicate code that you've added and other you clean up what you've done, and then once that's done, you write another test, you're in red again, and you start the whole cycle over again. Okay. Oh, and one thing that I wanted to mention also about the Mockist style. Which I don't know, maybe doesn't fit very well with the red-green refactor pattern, but in any case, Martin Fowler describes kind of an interesting thing with regards to the Mockist style of test-driven development, which is where you can do a kind of outside-in development with this Mockist style. And what that means, and it's particularly suited to layered applications. So you start at the top, so maybe the UI, and you mock out everything underneath, and you write your UI tests. Then you have the interaction with everything underneath defined by the mocks that you've created, and the behavior that you're defining in your unit test. And so then you go and you implement that behavior on the next layer. And then you kind of repeat this process and drill your way down layer after layer after layer. And even if you're not doing a full, layered application development in this Mockist way, you might be doing it with dependencies. So say you're writing a brand new framework for something, right? And it's all back-end code, but you're writing a brand new framework where you're going to have dependencies on different things that aren't even there yet. So you can start by writing, the main class, the main entry points to this back end, mock out the dependencies, because the great thing about Mockito, as you guys probably all know, is that you can mock interfaces. The implementation doesn't even have to be there. You just write the interface, you mock it, and then you can interact with it as if there's an actual implementation there. And so then you would write that first test, mock out all the dependencies, then once that's all done, you start working on the dependencies, and you write the test for those, and you drill your way in that way. So it's kind of like this outside-in development, which I thought was a really interesting way to think about it. Okay, hopefully I'm not boring you with all this. Let's talk about some of the characteristics of good test-driven development. So as you guys can probably guess, since we've already talked about it, is you would improve the design of your classes. And I really saw this very quickly when I was using this at my previous company. Another is obviously, and with regards to improving the design, one of the core things that you'll notice is having highly cohesive, low coupling classes and that interact with all their dependencies in this highly cohesive and low coupling way. And that's just due to the nature of having mocks and injecting them and whatnot. Next is bug identification. So if you have these full end-to-end tests, if something fails somewhere, you could have hundreds or thousands of tests that fail because of one dependency that now has a bug in it somewhere. And so the great thing about this Mockist style of test-driven development is that because you've mocked out your dependencies, when something fails, you don't have to spend hours tracking down where the bug is. Typically, if you've done it well and you've named your test properly and so on, when the test fails, you know exactly where the bug is. You don't have to spend any time looking into it. It fails and you know which method even needs to be fixed. And so that's a great artifact of the Machus test-driven development. And finally, a good characteristic of good test-driven development is having these fast tests, so that you know, as we've been talking about, having this test pyramid of very quickly running tests. Your whole suite of tests should take seconds or minutes max. For an entire application, your whole set of tests, obviously should not take an hour.
Well,
Anyway.
but this is referring to a bunch of unit tests, right?
Right.
Because when you have like
Yeah.
behavioral tests, that's
Yeah.
not achievable
But
anyway.
he's also talking about a pyramid, so
Right.
the ones that take long, there are less of them. That's when you get the
Right. Yeah. I'm focusing on the unit test because that's with test-driven development, that's what you'd be implementing. And because as you develop a new test and as you maybe perform some refactoring, you're going to want to run all of the tests for a test class and maybe even an entire package or whatnot. So as you do this time and time again, you're going to want to run them in a second max. It's going to be very annoying if it takes 30 seconds to run. Okay. Any questions so far? I'm almost done, I believe, and then we can have a full question and answer section at the end if you like.
Okay.
So let's talk about drawbacks. What do you mean drawbacks? Test-driven development is perfect, isn't it? There's no drawbacks. Well, of course there are some drawbacks. One of the things with the Machist approach is that you're coupling your test to the implementation. So, you're expecting that your class under test is going to call some method on a dependency a certain number of times with certain parameters or whatnot. And if that interaction ever changes, even if the end result doesn't change, then your test is going to break. You're going to have to go update it. Now, the thing is, Machist-style developers actually consider this a good thing because when you're writing your test, it forces you to think about the implementation. It forces you to think about, how your class under test is going to interact with these dependencies. So it's not it can be considered a bad thing, but you can be optimistic about it as well. So with stubbing, you sometimes need to write code that only exists in the test. You need to write code that only exists in the class under test, like getters maybe to get a list of objects that you need to verify, So that's one problem with stubbing. Yeah, and obviously with stubbing, the classic style, if you have a bug in a library somewhere that is reused all over the place, that's going to cause many, many tests to fail. So you don't have the same isolation that you have with the Machist style. What else? Oh, and one place, or two places actually, where TDD is not sufficient to fully verify and develop an application. One is with security software, and you can kind of imagine the reasons why. So, you might test drive the security software that you're developing, but you might test drive the security software you're developing, but it isn't going to be sufficient to fully verify that everything's working. And also concurrency is another issue. So sometimes you'll need more complex tests for all kinds of concurrency issues. And yeah, I think that's all I really had planned to say about drawbacks. Okay, so any questions?